All right, let's get started. So we're going to want to determine the arc length for our function x cubed over 12 plus 1 over x on the given interval from 1 to 4. So before we get started, why don't we actually go through and just go find the derivative of our function. It's going to be needed when we go to use our arc length formula. So our 3 is going to fall to the front, and that's just going to cancel out. We're going to be left with a 4 down below, and we lose a power on our x. 1 over x, its derivative is going to be negative 1 over x squared. Let's keep going through, and what we have to do in our formula is we actually have to square this out. So let's go through and let's see if we can't find the derivative squared. X squared over 4 minus 1 over x squared, and let's just write it twice because we're going to need to FOIL it. It'd be cool if we knew the formula, you know, the perfect square formula. You could just write it down, but if you don't, we have to FOIL. X squared over 4 all squared is x to the 4th over 16. We take it to our next term, and our x squareds will cancel out, leaving us with a negative 1, 4. We do our inner terms, and once again we have the same thing, just leaving us with a negative 1, 4. Lastly, we have negative 1 over x squared all squared, and that's positive 1 over x to the 4th. Well, if we combine our like terms, it looks like we have x to the 4th over 16 minus 1/2 plus 1 over x to the 4th. Hey, if that was x squared over 4 plus 1 over x squared, the only difference with the bottom would give you a plus 1/2. Keep that in mind. All right, well now let's go determine the length of our arc. The length of our arc from 1 to 4 of our function f of x is going to be equal to the square root of 1 plus the derivative squared. Dx. Fortunately, we've already solved for that. So it's 1 plus, and let's add it in. X to the 4th over 16 minus 1/2 plus 1 over x to the 4th dx. Well, the only things that go together are our 1 and our minus 1/2, and 1 minus 1/2 is equal to positive 1/2. So it's actually going to become x to the 4th over 16 plus 1/2 plus 1 over x to the 4th dx, all underneath our radical. Remember me making note before saying if that was a positive 1/2, we would have just had the binomial x squared over 4 plus 1 over x squared. So making this simple for us to factor up, we get the square root of x squared over 4 plus 1 over x squared dx, all squared. Fortunately, both those terms are positive, can never be negative, so when we take the square root of the square, it doesn't turn it into an absolute value, it just turns into the radicand. Now we evaluate our integral from 1 to 4, and we find out that we get x cubed over 12 minus 1 over x, and again evaluate it from 1 to 4. Once we plug it in, we find out we get 64 over 12 minus 1 over 4 minus 1 over 12 minus 1 over 1 for a 61 over 12, and that's a minus, a minus, a minus, a negative 11 over 12, which is going to become, what is that, 72 over 12 for oh so freaking convenient. Our answer is 6.